Identify the solubility equilibrium equation and the constant expression. The dissolution of the slightly soluble salt calcium fluoride, CaF2, is represented by the equilibrium equation. CaF2 is in equilibrium with Ca to the power 2 plus 2F to the power negative quad delta H greater than 0 quad. The solubility product constant expression for this reaction is Ksp equals Ca to the power 2 plus F to the power negative to the power 2 quad because solid CaF2 remains in contact with the solution. The system is at dynamic equilibrium. Understand the common ion effect. When sodium fluoride, NaF, a highly soluble salt, is added to the saturated solution, it dissociates completely to release sodium ions, not to the power plus, and fluoride ions, F to the power negative, into the mixture. Apply Le Chatelier's principle to product addition. Because fluoride, F to the power negative, is already present in the solution from the dissolved CaF2, it acts as a common ion. Adding NaF dramatically increases the concentration of fluoride ions, F to the power negative, in the system. To relieve this stress and consume the added product, Le Chatelier's principle dictates that the equilibrium position must shift to the left, towards the reactants. Determine the effect of the shift on the calcium ion concentration. As the system shifts left, dissolved Ca to the power 2 plus ions are forced to react with the excess F to the power negative ions to precipitate out of the solution as solid CaF2. Consequently, the equilibrium concentration of calcium ions, Ca to the power 2 plus, decreases. This confirms that option D is the correct answer. The correct answer is option D, adding NaF, because the reaction will proceed toward reactants.